Hey everybody, welcome back. Today we're going to talk about cloud applications. We're going to talk about what they are, why you might want to build one, and the differences to normal applications. Now this video will probably be a little bit shorter as I don't really have any specific demos or any specific slides to get through. Mainly this is week 2, module 1 in the blog post and just kind of a high level, more in-depth explanation of why we might want to go to the cloud. Now, the first thing to really consider here is, do you actually need the cloud? Okay, so that's something that is basically going to be a major well, not really a major sticking point, but kind of a major consideration that we have here. And if you're looking at this now, ignore all of the updates that need to be made. I still have some videos that have to go in here. Um, but do you actually need cloud services for your application? Or can you get by with a normal, standard C# application or an Android or a Kotlin application. Maybe it's an iOS. Maybe it's a bash script. Right? Does it make sense to actually go to the cloud, invoke all this extra overhead, deal with billing and management, all of the extra things that go with cloud applications? And if the answer is yes, well, then let's talk about building a cloud application. What do we typically look for in something that is in the cloud? So first of all, we are basically moving local installations, right? So you have a local packaged up application. Maybe you're deploying it to all of your customers, to all of your employees, whatever your job is here. And we're going to upload it to the cloud. By going to the cloud, it is now required to be on the network because otherwise we'd have no way to access it, right? It has to be a networked type of application. But with that, you get a lot of benefits. So we get scalability. We get scale up and scale down, meaning that if we have, 500,000 people accessing our application at the same time, in theory, or depending on how it is configured, the resources behind your application should scale up to handle that in a reasonable level of performance, right? So you get a decent quality service. Whereas if you had a normal application, maybe it's running on a local Apache or Nginx web server, whatever you're doing, you might not be able to handle that many users at once. But by being in the cloud, we can leverage some of the technologies to say scale up. Or once our initial hit is gone, maybe we trickle back down to 500 concurrent users, we can scale down our resources seamlessly and automatically. And why that is important, other than providing a good quality of service, you have to pay for that. So everything that you're doing in the cloud, you're paying for, and I'm trying to really stress that point that you pay for what you use. If you are paying for 500,000 concurrent users, that could get very expensive very quickly. But if your cloud environment is configured to scale up and scale down seamlessly, you only pay for what you need, and then once that wave of users goes away, you scale back down and then you don't nearly, pay as much. So that's one consideration here with a cloud application. Scalability is nice, but also keeping an eye on what you're paying is kind of useful too. So let's first talk about your needs. And I've got a nice little kind of ham-fisted argument here of why you would need it. But for one, we are making the assumption that you need to be in a networked cloud-based environment, okay? Basically, you have to be up there. And again, if you don't, and it's fine to not be up in the cloud, then maybe you don't want to go through the overhead of planning, of figuring out which provider you want to use, and following a buzzword, for lack of a better term, I suppose. But one other thing that we can do in the cloud, for instance, is that we can take these unwieldy, bulky applications that we all tend to build, right? There's nothing wrong with it. But from a software engineering perspective, from a system administration's perspective, having these big unwieldy programs can be difficult over time. Okay, so separate topic now. We're assuming we're in the cloud. Let's say I have built up a very, very large storefront application. Maybe it's a React application, which we go through the code web demos that I've got for you. One of them is doing exactly this. Or maybe you have a big type of ERP system that you're, trying to construct because you want to get away from licensing concerns or something of that nature. And you're building up this massive .NET, you know, C# type of web-based environment. And it's getting very bulky very quickly. You have lots of dependencies, you have lots of moving pieces. Maybe one of your coworkers accidentally updates something that just broke the entire application because you have so many dependencies. Might make sense to take that and break it up into a bunch of, say, microservices. That's one thing you can do in the cloud. They don't have to be microservices, they can be standard, normal services, but they are separate. They are basically entities in and of themselves. So we're going to break our applications up into services. Rather than one big, massive application that handles user login, handles data management, data entry, analytics, performance monitoring, logging, everything that we need with a good application, why not make each of these components be its own separate service? Depending on your perspective, it could be a good thing, it could be a bad thing. If it is all separated out, we get into the realm of compartmentalized, reusable code. We can version pieces individually, don't have to necessarily worry about massive integration steps or massive system deployments. Everything is its own separate, well-documented and well-structured service. Maybe your login system is using, we're going to use like Google IAM for logging in, but maybe you have a service that handles authorization for various components. Or we're going to reach out to BigQuery to handle sifting through terabytes of data rather than building some kind of custom script in there to really, make SQL Server go really, really quickly. Effectively, what we're looking at here is taking all these services that are available in the cloud, using them to our advantage, and kind of splitting apart our applications. And with that, we can also add on scalability, we can add on logging. Everything that we're going to be talking about this semester can apply to each service individually rather than one giant construct. So it's kind of a nice benefit that we get. And one question you might have is, okay, this is cloud applications development. Really, we're looking at the cloud as a whole and how you can leverage these different services to build your applications. All right, we're going to talk about a lot of different services this semester. We're going to go through Kubernetes. We're going to go through endpoints. We'll go through cloud functions. We'll do virtual machines. Kind of the entire gamut of what is available in the cloud. It's going to be up to you to pick and choose how to build your applications. You don't need to use every single thing. You could just use one, as long as your application that you are building is taking advantage of these nice benefits that we have in the cloud. Again, with the real world perspective that you are paying for this service. And that's not necessarily a bad thing. It's a wonderful service to make use of, whether you're doing Google Cloud, AWS, Azure, DigitalOcean. I think Alibaba has a cloud service now. But you're basically contracting out either your infrastructure, your platforms, or your software, or your X as a service, depending on how the industry goes. So basically, you will pay for it. And with our cloud-based applications, since we're kind of running towards the end here, I'm not going to go through every single bit of our blog post here. I'll let you run through that. But keep an eye on your security. And this is something to really stress with cloud applications. Keep in mind that regardless of which application you're building, and regardless of what you are doing, you are now putting it on a network. Okay? Excuse me. Not only are you putting it on a network, but you are putting it in a publicly known environment. Okay, so make sure that regardless of what you're doing, whether it is a simple little CRUD application where you're just updating a database, maybe you're building a multiplayer game server, and you need something fast and performant on the back end to capture thousands of user data simultaneously. Pretty simplistic, but what if you're dealing with employee records, social security numbers, payroll sheets, home addresses? You are putting this in a public forum, whether it's living there or just getting transformed along the way. It is possible that some bad faith actors will try to discover that. Keep in mind that Google, Microsoft, AWS, any of these providers live in well-known IP address ranges, and there will be automated scripts out there trying to find holes constantly, all the time. A story I like to tell in class, obviously you're not in a physical class with me, but one semester I had students playing around with virtual machines. We set poorly constructed temporary passwords on some servers, and they got taken over by a botnet that wanted to do some Bitcoin mining. Nothing was exposed outside of these virtual machines um, existing, really. Like, we didn't have any crazy security, we just used the defaults, but a bad password leads to a breach. And you have to keep in mind that by going to a well-known cloud provider and maybe using their infrastructure, you are effectively putting your faith in their hands of their ability to secure things. So be defensive in your security. Don't just trust the perimeter. So don't trust the nice firewall around your little walled garden. Be defensive internally as well as you're building your application. Build in constant authentication and authorization. Make sure that you're encrypting everything. All of your hopefully common things that you would do locally, make sure you still practice that in the cloud. I just kind of wanted to really hone in on that point. But other than that, we will basically be getting into a whole bunch of various services throughout the semester. So just pick and choose what you're going to need. To me, it's good to get as much exposure as possible to all the services that are out there. Like, we'll be going over cloud functions in the near future, whether you're automating them, whether you are, scripting them out through the Cloud Shell, building them in the editor, whatever you're doing, useful tools. We're going to look at BigQuery. We'll look at cloud storage. We're going to look through pretty much a good range of things in our cloud platform product portfolio here. Hopefully, if you don't want to use Google Cloud long term, anything you do in here should be transferable to AWS or Azure. Syntax will be different. The browser interface is going to be different, obviously, right? Different providers, but the ideas are pretty much going to be the same. And even to the point where some of these are actually interoperable as well. Let me give you a quick example and then I'll sign off because this video is getting a little bit long. But let's say that you build up a really nifty application in Google Cloud here. And then you want to start maybe migrating to AWS, or you want to separate out some of your concerns so that you're not tied to one particular provider, assuming that's a possibility. A lot of these applications are accessible via RESTful calls. As long as you can authenticate, there's nothing stopping you from, say, building up a cloud function in Cloud Platform, having it talk to an AWS Lambda function, and then pass something into, say, Elasticsearch. Again, a lot of these are built on open standards, and as long as you're properly authenticating and practicing good security protocols, it should be transferable knowledge all throughout. Anyway, hopefully not too much of a rambling video, but it's kind of a nice little intro into using these technologies for building applications. So I will see you in the next video. Bye, everybody.